This video, I will show you find the quadratic model by least squares method. To find the quadratic regression by hand, you have to solve the following system equations. Here's the one. You will substitute all the points into this system equation. Then you will figure out the A, B, C. Then you can figure out the quadratic regression equation, y equals ax squared plus bx plus c. We want to use that least squares method to model this quadratic curve. Here is the all points you got from GeoGebra. First of all, I will go to Excel to figure out the x squared, x third power, x fourth power, xy, and x squared y. Then get the sum of each column. Then I copy this table to the Word document. When you copy the table from Excel, remember you need to change this into the math type. Then you will get the data like this. So we put into given here system equations so that you will get this. Then we will write this system equation into matrix form. By graphing calculator, you will get the ABC. Then this will be the quadratic model by least square method. For the graphing calculator, I will go to second matrix, then go to edit. It will be 3 by 4, which means 3 rows and 4 columns. After you put in, then you will go to quit. Then go back to matrix again, go to math. Then upper arrow get RREF. Then go back to the matrix. I need A. Then parentheses, enter. You will get this is A, B, and C. This is the function given by least square method. You could see how well it fit the curve. Then you can export this image and copy paste to the Word document. So we got figure 5. This is the quadratic model given by least squares method. Since we already use 4 methods to figure out the quadratic model, we want to figure out which one is the best fit. We want to use SSE to figure out which one is the best fit. SSE is the sum of square residual error. Basically, this is an unexplained variation. We have SSR, that is the sum of square regression error. This is an explained variation. SST is the sum of square error total. For SSE equals the sum of yi minus f of xi squared. F of xi is the regression equation we got from different methods. For SSR equals f of xi minus y bar, that's the mean of the original value. Then you square, you will get the SSR. For SST is the sum of yi minus y bar square. From this diagram, you could say SST equals SSE plus SSR. Then for correlation coefficient square equals SSR over SST. We can write down 1 minus SSE over SST. In other words, when SSE increasing, then R squared is decreasing. We need to figure out which quadratic model has the smallest SSE. Then that quadratic model will have the greatest R squared, which means the quadratic model which has the smallest SSE is the best fit. So I go to Excel. I get the equation by matrix, by vertex form, by derivatives, by least square regression form. Then we figure out the SSE. So we get the sum of this SSE here. You will get this table. We will copy this table to the Word document. But remember, when you have this, we call this is Excel notation. You have to change into 0. I copy the table from Excel. Remember, if you see something E negative 0.5, this is Excel notation. It's not allowed in our Math IA. You need to change into 0. Then you compare the value of SSE. You will see the quadratic model given by least squares method has the smallest SSE value, which means y equals negative 0.142x squared plus 1.752x plus 2.827 by least squares method is the best fit.